Hello and welcome to another free code session. My name is Jason Bach and we're going to continue on with Pony. We're going to go into variables. Just to review quickly, I think last time I went through structs, type aliases, type expressions. We got into literals as well. So that's what we did in the last episode, and we're going to move on to variables. So there are local variables. Hopefully by today, I mean in this episode, variables and operators, control structure. Maybe I'll finally be able to write a legitimate program. So, all right. Within a chunk of code, they are local to that chunk. Yes. Final local variable, var is used, let. And I think we already talked about that, but we'll see if there's a difference with variables. Good, it does do type inference. Good. Can I miss out both the type and initial value? Makes sense, because if you're inferring it. I found this interesting with Pony, is that it does have some kind of conventions with naming that some I like, some I don't, but when a language gets this opinionated about naming and they have that underscore for it to be private, a field, and that feels a little weird to me, but whatever. Exactly what its scope is depends on where it's defined. Exists for when they are defined until the end of the current scope. Yep, makes sense. Local variables, var let. Assigned once, exactly what I thought it would be, because that's what they talked about before. And if you do a let, yes, it has to be assigned immediately. Makes sense. I haven't seen the const. Like, there is no constant, at least not that I've seen yet, but maybe there are. I would say, yeah, let would be by default if you can do it, but, you know, if not, just use var. Fields. I think we talked about fields, and yep, the underscore is private, otherwise it's public. And I think because they mentioned that there's no inheritance, there's composition, and there's traits and interfaces. I'm guessing there is no class inheritance. I'm guessing. Which means that's why you don't need it protected, because there's nothing to protect yourself from subclasses. So, in any event. They talked about this before with var let. Yeah, and a let would be no matter the type of the field. Oh, for both, okay. Yep, assign the constructor. Yep, okay. And, okay, so the initial assignment has to be done in one or the other, okay? That makes sense. Please note, assignment of a value to a field has to be explicit. Set hunger, level. Oh, you have to do it within there. The assignment of fields not done at the definition level has to be done in each constructor, because even though you set it here, I'm guessing it can infer that it did it there. Okay. As for variables, using var means a field can be assigned and reassigned. Yep. That makes sense. Your field declarations appear after methods. No. Oh, so it also enforces and again, I don't actually mind that, because I usually do type definition or class, fields, constructors, so this actually works in my favor, but I can get where some people will be like, I don't want to be told where to put my stuff. So, yeah, I'm still kind of wondering, it doesn't seem like you can have a method that doesn't have a method body, unless you just take that off. Is that okay? Oh, you have to specify a body. Okay. Okay, I'm just wondering if you can actually do that or not. Some types of field can be declared using embed. Only classes or structs can be embedded. The interfaces, traits, primitives, and numeric types cannot. Field declared using embed is similar to one declared using let. At the implementation level, the memory for the embedded class is laid out directly within the outer class. Oh, what's an outer class? Contrast this with letter var, where the implementation uses pointers to reference the field class. Embedded fields can be passed to other functions in exactly the same way as letter var fields. Embed avoids a pointer in direction when accessing a field and a separate memory allocation when creating that field. By default, it is advised to use embed if possible. Then the embedded field is allocated alongside its parent object. Exterior references to the field forbids garbage collection of the parent. That doesn't make sense to me. I would need a better description of this, because I was starting to wonder, is this like a static type of thing? Like you don't need to... Well, then you use a primitive, but a primitive doesn't have fields, but it can have functions. So I don't understand why... I still don't understand why I'd use embed. So, globals. What a bad idea. Okay, well, I agree. Generally, I don't try to do that at all. Shadowing. Source of bugs. Shadow a variable, the compiler will complain. Makes sense. Okay, we have variables. Operators. Arithmetic comparison operators are the most common. Operator aliasing for functions. Okay. So x add b, yep. Any type can provide its own add function. The programmer can then use with that type if they want to. Really? So it's a naming convention? I can never have my own add method? Huh. When defining your own add function, there's no restriction on the types of the parameter or the return type. Defining a plus function. Okay, so I guess, because like in C# you have operator overloading, and you can override a plus, but you can't, there is no, how do I want to say this? You don't just put an add method on your class. This one you do, and all of a sudden, hey, I can add them, which is kind of interesting. So yeah, if you have a pair here, you do that. They're private. Then you add a pair to pair, and then okay. It's possible to overload infix operators using union types or f-bounded polymorphism. You don't have to worry about any of this if you don't want to. You can simply use the existing infix operators. But I guess if there's a notion of packages or libraries or whatever, this would probably be something you would want to do. Oh, the mod. That's interesting. I was wrong about that. This is remainder. Oh, that's right. Module. Because the program I was trying to write here with clats is the remainder, which is actually what I want, because if it's divided by 2 and it's 0. Okay. I was right, just not thinking right now. And or equality. Unsafe. Okay, so those are unsafe. Module unsafe. Shifts. Okay. Partial addition. And partial subtraction. What does that mean? That's an interesting one. How would you partially add? So if you do 2 plus 7, you get maybe 8. Because you're partially adding them? I don't know. Or like half and half of each. Maybe they'll talk about that later. Short circuiting, yeah, that's pretty common. Yep. Cannot be used with the operator in front of their type. Unary operators, negate, yeah. Precedence, unary operators always bind stronger than infix. We will get a 9 if we evaluate the addition first, and 7 if mathematics. The rules are you do this first. 2 times 3 is 6 plus 1 is 7. And most programming languages follow this approach. The problem with this is that the programmer has to remember the order of people. Yeah. So, whoa, Pony takes a different approach and outlaws infix precedence. An expression where more than one infix must use parentheses. Wow, really? That is interesting. I don't know if I've ever met a language that did this. Maybe there are, but I'm just saying, me personally, I've never seen a language that forces you to specify what exactly it is. And I guess for clarity, that's actually kind of nice. That you have to be explicit to say, did I mean I want 1 plus 2 and then that times 3? Or I want to say 2 times 3 first and then add 1 to it. Interesting. Interesting. Okay. Arithmetic. Yeah. We all know that stuff. I noticed it wasn't like a arbitrary precision size value or like a big int. Maybe that comes later. Maybe. We'll see. And there was also intrinsics I thought I saw somewhere before. Maybe they'll start talking about that here. Safe code should check for overflow. Yeah, it should. Checks on arithmetic. Now I have in a runtime. Excuse me. Pony's default arithmetic. Proper wrap. Prap around semantics. Behavior like the max value plus 1 wraps around. Yep. Makes sense. Now they said there's no errors in Pony programs, so division by 0 is undefined. Throwing an error in division by 0 and introducing undefined behavior for that case. The normal division is defined by to be 0, the divisor 0. This might lead to silent errors when used without care. Choose partial and checked arithmetic. Oh, we'll get to that. Okay. So unsafe arithmetic. Unsafe arithmetic comes close to what you can expect from integer arithmetic in C. No checks, raw speed, possibilities of overflow, dogs and cats living together. Like in C, overflow, underflow, and division by 0 is undefined. Don't rely on the results in these cases. It could be anything, and it's highly platform specific. Division by 0 may even cause your program with a SIGFP. Segment fault? Is that what that is? Okay, I'm going to take a chance. I'm going to look this up. Who knows what this really means? Why do I get a SIGFP? To the Wikipedias. Signal sent to a process when it executes an erroneous arithmetic operation. Positive signals. Okay. So that's what the unsafe does. You just do all these, except you put the tilde there. Okay. Unsafe conversion. Each numeric type can be converted explicitly into every other type. So if I have an integer of 32-bit, 12, I can convert it to a 32 float. Much faster when converting from it to floating points. I-64 to F32. Example, undefined unsafe conversion. Example for undefined unsafe conversion is actually safe. Okay. Oh, because it's a 1. Oh, okay, I see. So that actually would be safe. Okay. Partial and checked arithmetic. Overflow or division by 0 cases that need to be avoided. Performance is no critical priority. Partial checked arithmetic offers greater safety during runtime. Operator's error. I thought they said there was no errors. Checked arithmetic returns a tuple of the result of the operation in a Boolean. That's interesting. So here's a try. We didn't talk about tries. So, because that's an unsafe add. Overflow detected. A checked arithmetic. So here's the matches. Okay. So those are the partials, and then the checked are actually explicit. There's no like operator for it. Okay. So partial will throw, even though I thought there was no errors, but whatever. A checked will return a tuple, and false means there was nothing. That's weird. You'd expect like a true to say, hey, it was checked, it's good. This is actually saying, hey, this failed. Or a false means it was, that's backwards to me. That would actually really throw me. And I guess this is a discard, and so you can say I don't care what the result is. I'm matching to say if the Boolean said that there was an overflow. But I like this, because again, this is getting at matching capabilities, and I like that. Okay. Partial as well as checked, and exceptions in every case. Yes. Understood? Yes. Floating point, yeah, handled by the standard. Division by 0 turns infinity, minus infinity. Unsafe arithmetic. Didn't we just talk about that? Oh, okay. This designer can have that. This allows more aggressive observations and for faster execution. Additionally, square root unsafe is defined. Okay, so there's different kinds. Makes sense. Control structures. Unless we have time to do the real work. You betcha. Opponent. I wonder if it has gotos, because I sometimes will surprise people when I do a talk in C# that you can actually use gotos in C#, but I highly recommend people don't do that. I should actually look through the Roslyn source code and see if they do any gotos. But in any event, so here's a true story. And I may have said this in a previous episode, but that's okay. Speaking of gotos, I was on a project about 10 years ago, I think, somewhere around that. And there was at the time, principal consultant something or other who was leading the project. And it was a WCF-based code base. And so I started looking at it, and I just stumbled across one method that had, and I'm not kidding you. So I was about to say I'm kidding you. I'm like, no, I'm not kidding you. I counted 8 gotos in one method. And I was just like, it's one of those things where you look and you're like, wait, I saw one, and you start counting, and it's like 8 gotos in one method. And I'm like, what the hell is this? I probably said even more explicitives like that to myself, but I was just like stunned. Like, this is, 2008, 2010, whatever. This is not good. And then I looked up in history, because of course you got to figure out who to yell at, and looked at who actually wrote this and found out it was this person. And so I sent him an email, and I was trying to be nice, but I'm like, why did you code this with 8 gotos? And he came with some poor excuse about that was the only way he could get it to work, and it actually makes sense, and it's how just the logic of the code works. And I was just like, wow. I was just stunned. Somebody who is considered to be the lead architect on the project is rampantly using gotos everywhere. I was like, oh, this is just not fun times. Anyway, so that was a learning experience. Control structures. Good old if. Okay, can I use integers and pointers? Conditions like I have a C, no. True or false if you want to test if a number not 0, a not 0. So how did my program not work? Oh, we haven't got the values yet, but if the remainder, then, okay, we haven't got the if and else's yet. Well, okay, so why isn't that working? Does it not like that I have parentheses here? I'm really confused. Oh, so now you need parentheses. Okay. There? Huh. Do I need an end here as well? I just crashed the program. You could hit that. Obviously, I don't understand this. var value. So I finally got this, but it never stopped. While value is greater than 1, do. If it's even, then you multiply it by 3 and add 1. Otherwise, you divide by 2. Huh, I don't know what I'm doing wrong? I mean, well, the classic one is 16 or something like that, because that should stop. Obviously, I don't know what a while does, because 16 just goes 16, 8, 4, 2. I'm just curious, if I say value is equal to value divided by 2, and then I print it out, what does that do? Can you actually do multi-line comments like this? Yes, you can. Yeah, it goes to 8. So obviously I'm a moron, because something's not jiving with me. Well, let's continue learning, shall we? And else if statements, but this quickly gets ugly, so you can do else if. Okay, that makes sense. Why can't I just say, so if A and B, and I already had if value, else, if then. Okay, everything is expression. Languages can have an if inside an expression. There has to be a separate conditional operator. Everything hands back a value. Your if statement hands you back a value. Your for loop hands you back a value. That means you can use if directly in a calculation. 1 plus if lots. Yeah, I like that. It may look weird, but if lots. Oh, if that's like a Boolean. Okay. If the then and else branches of an if produce different types, then the if produces a union of the... Oh, it could be a Boolean or a string. I like the powerful type systems can give a lot of expressiveness. I like that. But what if my if doesn't have an else? And the else branch doesn't exist. It gives an implicit none. So it could be string. That's weird though. That there's like an implicit. Why does it do that? Because it. Oh, because it couldn't match the if, so it has to be a none. Okay, that makes sense. Same rules that apply to an if applies to loops as well. So var could be, for name in this array, all the values do name. So match string x is this. This will give x the value Sarah, as is the last name in our list, because that comes out because 4s are expressions, so you'd have an x, string of none. Okay, that kind of makes sense. It's a little mind twisty for me, but that I can groove on that. Okay. 0 iterations, then it's wrong. This is where I'd love to have a send edit. There is no else block, the value will be none. Right. And you wouldn't have to say this because there's type inference. Okay. Yeah, it's no names. And here you have a string, it would be none. That makes sense. Okay, I like this. I really like this. Loops. If it allows you to choose what to do, but something more. Pony. While loops are very similar to those in other languages. Prints out the numbers 1 to 10. Just like if expressions, while is also expression. So this is like an else block and a while loop in Python. Python, the else is running while the while completes. Okay, so now I'm really not confused, but I don't understand. I don't understand what I'm not doing right here. So let's kind of just get my head around what I'm doing wrong here. And then let's print out this. And then let's comment this out. And run it. 16. I had a bug in my code. Not equal to 0. That means it's odd. Not equal to 0. Boom. There we go. Okay. And we should probably print out like the last value. So if I do this, I should see the 1 at the end, as I do. And then if I do make this 1, you just get a 1. I learned how to not write stupid, crappy code. Okay, we're almost out of time. Let's see here. While loops. So it wasn't the while loop. It was just a complete screw up on my end. Okay. Breaks. So while more names. List of names, looking for either Jack or Jill. Hey, it just feels like Link. You just take var names. If it equals that, you break with that. Otherwise, the else. Okay. Well, this is weird. Why do you have the name there? The line name appears at the end of the loop, so that will be our value returned from the last iteration if neither Jack nor Jill was found. Oh, okay. That makes sense. Okay. The else block, so this would not be a string or none because you'd have, no matter what, you should have a string coming out of it. I don't know if you just heard my cat meowing, but he's obviously not happy. Hold on. Come on. Come on. Here. Get a special guest appearance here. Come on. Come on. There you go. There you go. Yep. Come on. Tricky. Come on. How about there you go. Okay. Let me get my cat down there. There's my kitty. Tweaky, can you say hi? He's a very happy cat. We have 2 cats. This one's Tweak, and the other one is Mittens. And they're both very friendly cats. But Tweak, we've had for over 14 years now. And he has always been a very friendly cat, especially to me. Right, Tweaky? You're such a good cat. Yes. All right. So let's finish. So that's my cat. All right. So let's finish here. So that makes sense with else. Continue and move to the next. Yeah. Same thing like in C# with continue. Stops executing current iteration in the innermost loop. It's in. Stop hitting my mic, Tweak. Let's make sure that I'm actually still in focus here. Yes, I got it. Okay. Continuous execution in the last iteration. There are no value to return from the loop. Continue an outer nested loop. Fire factory code. 4. 4 iterating over a collection uses a 4. 4 in. Yep. We already saw like you can just create an array and then do values. Iterator, not an array. Yep. The iterator is not to be a particular type. I'm surprised they don't have like a trait or an interface to say, but maybe they do. Okay. Because the iterator, okay. You can think of the above example as being equivalent to all iterator. Yeah, same thing, more or less, that you have in C#. Okay. The variable's a let. Yes, that makes sense. You don't want to change it. There's a repeat until. Here we evaluate the expression in the loop, and then evaluate a condition expression to see if we're done, or we should go around again. This is similar to do while, except the determination condition is reversed. The language terminates the loop when the condition expression is false. Oh. Okay. We always go around the loop at least once with repeat. We not go around at all. Right, because you could just come right out of it. Suppose we're trying to create something we want to keep trying until it's good enough. We have a counter, repeat until counter is greater than 7, end. So you repeat. Yep, you do this until count. Okay. Okay, that makes sense. So actually I'm going to end right now because we're near the end of it. So we got all the way through counters, and we were able to actually get my program here to work. What I'd really like to do is like add them to an array or a list type, and then print them all out in like a comma-separated string, but not there just yet, but we'll keep hashing away at this. So thank you all for watching. Leave comments and questions below. See you in the next episode.